So, I'm coming back to speak with you about the farmers' practices to identify the livestock selection management and to try to understand the farmers' choices. So this work was made mainly with Julien Quénon. He is a guy working with me during a few months about the Smarter project, and mainly to analyze all this data I present to you. So this presentation is based about the resilience and efficiency traits impact on the system performances and modifies the farmer's breeding choice. And it's a presentation during the last EAAP meeting in Porto. And so this work has two aims: how farmers can increase resilience of small ruminant farming systems, and how social acceptance and economic, social, and environmental benefits of breeding strategy are used by the farmers. So for the small ruminant livestock, it's a very important impact about the social, economic, and environmental importance for many rural communities in the world. And I'm looking for my phone for the time. Maybe I forget it. Sorry. It's here, huh? Yeah. Thank you. Probably I forgot my head in the same place. So, okay. And this impact of the small ruminant livestock farming system are important in the world, and the sustainability of them are very, very important. And the choice of breeding goals depend on different elements of the environmental dimensions of the farms. Mainly, the question of resilience or robustness could be make a question about buffer, adaptive, transformative capacity in changing and uncertain context. For example, the resistance to heat stress or resistance to parasitism. And efficiency is an important point about the resources used by farmers and by animals. That means it's important to have a point about feed intake and about land use. So in the Smarter project, this question about sustainability are very important with the resilience and efficiency new traits, and to adjusting breeding objective to small ruminant farmers' expectation are very interesting to have actual breeding practices and point of view about the sustainability. So two questions are important for this talk. It's what type of criteria, genetics or not, do farmers and breeders use? The difference for us, and to be clear, between farmers and breeders, farmers can use genetic progress, and breeders are more in the production of the genetic progress because they use RAM and use, for example, with good quality, and they are included in the genetic organization. The second question is which traits do you think are relevant to increase the sustainability of their farm? For that, we propose to work with the farmers' practices, and we decided to conduct interviews with farmers and breeders to collect different information. And these interviews are based to identify livestock selection management and to understand the farmer's choice. So this is a global method with data collection, data editing, and statistical analysis. Of course, if you have questions, ask me. So the data collection was based with 15 breed sheep and goat, different type of system: milk production, meat production, wool production, and dual purpose production. and with different local conditions, different countries, with extensive, semi-extensive, and intensive management. It's a flashback from my presentation this morning, and I go back at the end of the presentation. So with the same design of bottleneck, and we work with 5 different countries: Greece, France, Italy, Spain, Uruguay, 15 breeds, and different type of system and different local conditions. So this is a presentation of the global data from 262 farms with 4 breeds in France, 2 from dairy sheep and 2 for meat sheep. 6 breeds in Greece with milk production, goat production, and dual purpose. Only with 2 breeds goat production in Italy. Only 1 milk sheep in Spain, Asaf breed, and 2 breeds, Corriedal and Merino, to produce meat and wool, or wool and meat in Uruguay. So the questionnaire of the interview is based with different type of question. And for example, the question for like this about selection indexes are very important for you, farmers, for selecting breeders, and the farmer must to respond strongly disagree, or strongly agree, or never agree nor disagree. This case is not very interesting because I don't know, it's not very easy to treat the data with this. So another type of question is, for example, how relevant for you are the following traits with, for example, the UBV availables for selecting animals. And there are different traits like milk quantity, and farmers say, yes, for me it's very important, I put 10, or it's not relevant, it's totally irrelevant, I put 0, or it's not available for my breed, etc. And there are a lot different traits like protein content, fat content, etc., etc. So my talk is not to present all the variables, but the method and the results. So we have 5 different type of data about crops management, like rotation, fertilization, crop protection practices, etc. A second group about folk management, size, breed, reproduction, culling practices. Genetic management practices, about the knowledge and the use of EBVs. EBVs evaluating breeding value. Our selection indexes, which are criteria and traits used by farmers to select, to breed animals, and sustainability related traits to select in the future. And the last part, it's the social technical information about involvement in the breeding and performance recording organization, opinion about genomics, crossbreeding, and different tools, and opinion on information to share between countries and organizations the tools and the results of genetic progress. So to analyze the quantitative data, we use a method proposed by Girard and et al. In 2008, and it's a combination of the practices to produce a sort of categorical variables with a sort of description from an abundant diversity of response to an acceptable one. How it's possible to merge all the practices to one meta practices. And for the quantitative data, we use a calculation of relative indicators. For example, artificial insemination. Example about qualitative data. For example, the farmers say, yes, milk persistence over the years, it's important. Resistance to disease or to high temperature are important. Greater lamb growth, feed efficiency, etc., etc. And for each type of farmers, we have a different response about production traits, robustness trait, and health traits. And for share this and to merge, we can have 4 initial unique response to 2 different crises. That means for the farmers, robustness and health are important, or for this, it's production. And you can see for the different combination, we have at the end 2 classes. It's to limit the diversity of the response and of the variables. So, in the analysis, in the statistical analysis, we use the 12 active variables and 29 supplementary variables. For the active variables, it's about flock management, like the replacement rate, the percentage of artificial insemination used in the flock or the herd, use of animal insemination, or on the side, natural mating, only artificial insemination, or both. And for the genetic management practices, we use the data about the culling criteria, the number of culling criteria, the type of culling criteria, the type of criteria used to select animals, the number of selection traits used, the number of traits to increase sustainability, and the new traits that the farmer wants to introduce in the genetics program. For the social technical information, we have 3 variables. One about the changes to make selection indexes. No change. It's okay like this. More traits are necessary, or new index with different weighting between the different indexes are important for the breeding program. This variable, it's about the breeder status. I'm farmer using genetic progress, or I breeder. I explained this just before. And the enrollment in performances recording organization. Farmers contribute to the recording data of the production, milk production, meat production, or no. Okay, and for that, we use a factorial analysis of mixed data and a hierarchical clustering. Okay? Some question about the method? Do you know this type of method? Yeah? No? Who knows this type of method of analysis of data? Yeah? Okay, so it's the same thing, just to precise if it's qualitative, quantitative, or categorical data for each data used. And this is for traits and indexes. And this is the supplementary variables about crop, livestock, breeding organization. So, what about the results? When you make the analysis of this data, we can have a projection of all the variables and all the farmers on a map with 2 axes. And the first axis one is determined by the level of integration of small ruminants farmers in the social technical system of breed selection and performance recording. That means, on one side, on the left part, it's a low level of integration in the social technical system of breed selection or performance recording organization. It's mainly farmers, not breeders, farmers. They don't know what are EBVs in the genetic progress of their breed. They are not enrolled in performance controlling organization. Generally, they use natural mating only. They don't use genetic criteria to buy breeding animals. They prefer other type of criteria like the aspect of the knowledge of the farmers, of the reputation of the breeders selling these animals. And on the side, it's a reverse. There are breeders enrolled in the performance controlling organization using artificial insemination only. And it's a high level of integration in the social technical systems. For the other axis, it's determined by a small ruminant farmer's view on sustainability and the strategies they intend to adopt to increase it on their farm. And on the top of the graph, it's farmers with little interest in adding new traits in the selection indexes or nor increasing the sustainability of their farming systems. They no need new traits for sustainability. Sustainability is not relevant objective of the farmers, and they are satisfied with the current indexes. And the production-driven management for culling are the more important for them. On the bottom, it's a reverse. Farmers with high interest in adding robustness-related traits in the current selection index to increase sustainability of their farming systems. And sustainability is a crucial objective. They are unsatisfied by the current indexes, and they ask for robustness and health-related traits in the indexes. With this analysis, we can combine and the hierarchical analysis permit to produce 3 groups of farmers. One group on this part of the graph is mainly with low level of integration of socio-technical systems, but with 2 subgroups, more with little interest for sustainability and a large group in the bottom for interest to adding robustness traits in the indexes. And this group could be qualified like non-genetic farmers because genetic approach, the genetic tools are very, very low, far of their preoccupation and their knowledge. And they are seeking robustness and multifunctionality of the farms of the animals. For the second group, on this part, it's mainly high level of integration in social technical systems, and they are with little interest about robustness trait, and they are not very interesting to increase sustainability. This group could be qualified like genetic farmers. That means genetic it's important for them, and they know which are ABVs, which are the different tools and opportunities to make breeding with genetic index. And for them, they are seeking production efficiency. And these groups are more important with 145 farmers. It's mainly breeders. And these breeders, they are very integrated in the social technical system, and they are very interesting by the robustness trait, and they want to increase the sustainability of the farm by new traits. And this group is seeking production efficiency and sustainability of their farm. Yes?
How did you define the number of
Sorry? So it's defined by the definition of mathematical level. It's better to have 3 groups because the diversity inside the group is more control. And if you make, for example, 4 groups to cut this one, it's not completely better because there are important link between this group. Because here it's just in a two dimension, but you can get in mind it's with different a third, a fourth, a 5 dimension. And
was an automatic decision?
Yeah.
Okay.
Exactly. So we try to make with 4 or 5 groups if it's better, but I go to present the different characterization of the groups is better with the 3 groups only. So the first group, non-genetic farmers seeking robustness and multifunctionality, they are not enrolled in the performance recording, less knowledge of genetic, less use of the tool of genetic progress. Selection of animals are based on non-genetic traits and called on functional traits. Mostly they are in French, in Greece, meat sheep farmers. It's a smaller flocks of the sample. of these interviews. Generally, it's multiple breeds flocks with different breeds in the same flock, and there are lower replacement rate. And the percentage of meadow and grassland are very high in the unit of agricultural area. The second group, genetic farmers. The production is a very important driver about flock management. It's mostly Greek dairy sheep farmers. The percentage of meadow is low, and they use a low level of pesticides, and the selecting non-production traits to increase sustainability of their farming system are important for them. The third group, breeders seeking production efficiency and sustainability, is mostly in Spain and Italian breeders and Uruguayan farmers with a difference about some element. But the problem is Uruguay sample is very, very short, little, and it's difficult for this farmer to explain the diversity of their system in the whole group of the farms. It's a bit problem of methodology about the non-equilibrium between all the countries. This group, it's the large flocks. For Uruguay, it's true, with low percentage of meadow and grassland. Meadow for the grassland is an important grassland area, and meadows are a reduced level. High use of pesticide. This is not true for Uruguay. And the demand of flock configuration practices, farmers higher use of artificial insemination and a higher replacement rate. They are strong. They have a strong knowledge in genetics. They are breeders, and they are enrolled in performance control. They are satisfied with the current indexes to ensure the sustainability of their system. Some element about the difference in quantitative data for the different groups. The flock size is very different for the third groups with a larger flock or herd. I think we say flock for sheep and herd for goat and cow. Grassland in agricultural area, it's different for the first group. It's more important than the two other groups. The use of pesticides is completely different for the three groups. The percentage of animal insemination are different between the first group. They doesn't use they don't use animal insemination. And the two other groups use largely this technique. The replacement rate are different for the different groups, and the number of breed in the flock is just different and more important in the first group. Yes?
I'm just a bit surprised by the replacement rate.
Yeah.
It's really high for those which are looking for sustainability. It's more sustainable to change more cow, more goat or sheep, or
yeah. So it's important because it's generally a more intensive system, and it's breeders' systems. That means to maintain the genetic level, they can have a high level of replacement animal for different criteria like production, mastitis, etc., for example. Yeah? So another point is generally this is farmer, and mainly breeders. And the level of selecting and replacement rate are higher for this type of farmers, for the breeders. So now some point about the discussion of this result. What about sustainability? For the three groups, we can have a general approach about the sustainability. For the farmers of first group, they don't know ABVs, and they can have the link between traits, ABVs for sustainability, and their selecting practices. And another part of this group is thinking about new traits are necessary to put in the indexes for sustainability. For the group 2, it's mainly farmers who we think about current indexes for sustainability are now interesting, and it's not necessary to change them. And for the breeders group, group 3, we can see it's half part for current indexes meet sustainability, and new traits are necessary to increase sustainability. So the interest of the issue of sustainability varied among the different farmers, breeders, and the confidence in genetic tools and their relevance to increase resilience are different among the farmers. And we can have a question about what extent the smartest objective fit farmers' expectations. And mainly, I come back in the conclusion, mainly with the breeders and the farmer could be they have different point of view about this. About the livestock farming system, some general comment. We can see the first group, it's goat and sheep for milk and meat producers. The second group, it's mainly for meat, for dairy sheep. And the third group, it's more important for goat. It's mainly the more important goat producers and the milk producers. There are no overlap between groups and livestock system. Breeding management strategies and view on sustainability do not seem to depend on livestock species for farming systems. And this point about the country, we can see there are overlap between groups and country. Socio-technical element could explain the difference between the groups. The first group is mainly France and Greece. The second group is mainly Greece farmers. And the third group, it's France, Italy, and Spain. Uruguay is a smaller sample, and it's difficult to have a good conclusion about this country. That it's interesting, there are 3 points about the level of structuring the breeding selection systems, the level of dissemination and technology and knowledge of genetics, and how share knowledge among farmers on specific topic. I try to come back with the presentation of this morning with the different breeds and the different country to try to see if it's more and less easy to qualify the type of management and the country and breed. So for the Scopelos breed in Greece, the main part of all the part of the farmers are in the group non-genetic farmers with robustness and multifunctionality interest. For the Italian farmers with Alpine or Sardine, it's mainly breeders, production efficiency and sustainability interest, but a small part for the second group. For the milk sheep production, we have 2 parts in France. For the 2 breeds, it's in equilibrium, with non-genetic farmers, group 1, and breeders production, group 3. In Greece, depend of the breed, it's mainly non-genetic farmers with robustness and multifunctionality for the Chios, Lacaune, and Asaf breeds, and a small part of Asaf breeders, farmers with genetic farmers production efficiency, the group 2, and the group 2 also for the Frisarta breed. And in Spain, only with Asaf farmers, it's only breeders with the interest of sustainability. And for the meat sheep production with milk or wool, in Uruguay, it's mainly the group 3 with a small part of the group 2. For Butsko milk and meat in extensive system in Greece, it's the group 1, non-genetic farmers. And for French farmers producing meat, it's mainly non-genetic farmers and a small part of breeders for the group 3. Yes? So new involvement, it could be very interesting to use performance data of the farm, for example, milk production, economical results. They are missing in this work to objectivize and to develop difference across the different groups. However, such information were hard to access because the diversity of socio-technical environmental, the variable could be non-available, and the milk record database could be difficult to have data about this, milk or meat production. The diversity of production in sample farms, milk, meat, wool, could be a complex situation. And in the case of these interviews, already quite long, 2-3 hours, and it was impossible to include a section about farm performances. But could be interesting, and in this case of interviews, only we have a declarative information of the farmers. So to finish, some element take-home message about this presentation, this work. Not all farmers have the same level of genetic knowledge and the use of genetic tools. This is important because in the countries, the relationship between geneticians, between advisors could be very different, and the genetic knowledge of some farmers, it's a problem to develop the genetic program. There is no significant overlap between breeding management and breed farming country. The sustainability is a major concern in the main part of the farmers, but the levers used by farmers are different. Health and robustness could be for farmers more important. For other one could be the productivity of meat, of milk, and for some farmers it's the multifunctionality of the flock. So the question could be interesting. It's about the conclusion of the Smarter project. It's finally if the goal of the Smarter project are really correspond to the farmer expectations and their needs to adapt their breeding systems. And we can see a hiatus, a gap between the breeders' preoccupation and the farmers' attempt, because farmers are not in the same interest than the breeders. And this question is important for the goals of genetic program. And to finish, it's a talk about a verbatim about a farmer. Genetic progress will be difficult to maintain as it's because climate change will force farmers to adapt rather than relying solely on animal adaptation or selection. That means for farmers, genetic progress could be limited by the impact of environmental dimensions. So I have a great acknowledgement. Yeah, it's finished. Perfect. For all my colleagues from University of Thessaloniki, from INRAE in Uruguay, from Ovigen in Spain, and in Aral from Italy, and my colleague Julien Quenon, working on this work very hard, and Nina Oussay, who had a training period working about the Lacoon breed, for the collection and the analysis and all the time during these years of Smarter project and the partners. Thank you very much, and I have a question for you. Some question? Are you surprised about the results? Or? Yes? For what, for example?
Maybe the number of breeders that really don't know about genetics.
Oh, yeah. We were surprised too about this. And a large part of the questionnaire was based on genetic dimension, traits, ABVs, etc., etc. And when we speak with the colleagues from Thessaloniki, quickly they said, yeah, but for farmers, genetics tools, genetics index are not very known and could be difficult for the questionnaire.
Abstract.
Actually, that's why we wanted to include the question, do you know what selection index is? Because there were so many questions about genetics and indexes, but we weren't really sure that we would find farmers who know what these tools are.
Yeah.
There is a question.
It was more a remark because at least in France, for all the meat production, they don't maybe they select they don't do AA or they always keep the same male sire. So
Yeah.
there is maybe something there too. They don't look at genetics there because it's like there is less work, lab work, than in milk, in milk system.
Yeah. So I think for the French case, because I know more this case, we have two breeds in milk production. Lacoon with a very, very hard and large technical advising in the farms, in the Roquefort area production. And with Manège Tête Rousse, there are different breeds in Pyrenees, and these are the farmers with the high level of genetics and very, very closer than the approach of Lacoon breeds. And we can understand that the genetic approach, and the main part are breeders. That means they are very, very closer about the genetic issues. And for the meat production, we chose these two breeds, Côte du Lot, because in the project Smarter at the beginning, it's important to have a focus with a crossbreeding. And Côte du Lot, it's interesting breed and production because there are 3 different breeds with crossbreeding to obtain a final product, final lamb production with a crossbreed between Côte du Lot and another one. I forgot it, the breed. So to have a crossbreed animal lamb, and could be interesting to have this. But the problem is the organization of a genetic program are very, very so far from the farmers, and many criticism about the organization of the breeds and the different level of crossbreeding, breeders, etc., are very, very important for these farmers.
Are the farmers buying their FQ directly, or they are doing the crossbreed science?
Depend. Generally, there are one producer for Côte du Lot and a final producer to produce lamb, and they are crossbreeder. Yeah, and we have exchange with the producer of Côte du Lot. And for Roman, this was very interesting for us to study this breed because it's a breed using more and more in a new situation. For example, in culture area where it's a cropping region, where farmers try to use frock to clean the field during winter, and to have agroecological approach for new process of crop management. It's not this case of photo because it's an animal from INRAE experimental station in Aveyron. But there are different interviews in this case of crop production. So the social technical dimensions are very important. And we'll try after the coffee break to explain and to understand which could be social technical system with the game of Lego. You make it. Other question? I don't know for the timetable.